We'll start by taking a close look at a column. So we see our column has a cap, and as I note here, it pulls off, and it has a plug in the bottom that unscrews. There's a stopcock. It's really much like a burette. I've also included a close-up of a frit, because you're not going to get a chance to really see the frit, and it's important. A frit is a kind of permanent filter. It's made out of ceramic. Water will pass through it, but beads like our resin beads will not. So it forms a permanent bed at the bottom of the column that allows us to use this tool over and over again without losing any of our resins. So here's the column that's ready to use. We're going to zero in a bit here. Notice that water layer on the top Heather's pointing to. The column is saturated. You must never let the column go dry. Never let the water level get below approximately that mark. Now we'll move on to testing the column. The column's resins are saturated with acid protons that are ready to be exchanged for the metal ions we're going to remove from the sample. But the water around the resins needs to be relatively neutral in pH in order to get a proper reading. So we're going to test the pH of our water sample in the column. First, Heather removes the plug. Then she's going to remove the cap. Now she takes about 10 milliliters of water, carefully pours it in there. Now you notice that even though she poured the water into the column very carefully, it still deranged the beads. That's okay. You'll notice now that the water runs quite slowly through the column. This is about how fast your sample is going to run. We'll zoom ahead a bit here. Now we're nearly down to the bottom. We'll watch the drips go through the last of the column. And then turn off the stopcock just as we get to the top of the beads. There you go. Now we're going to take the sample, 2 drops of phenolphthalein, and the bottle of sodium hydroxide titrant you will be using to titrate. 1 drop. The column is ready. Our sample turned pink with a single drop of hydroxide. If yours does not, run more water, 10 milliliters at a time, through the column until it does. It should turn pink with no more than 1 or at the most 2 drops of hydroxide, or the water in the column is still too acid for the column to be used properly. Now we'll prepare our sample. For this we need DI water, a sample, and a 50 milliliter volumetric flask as shown. So Heather uncaps the flask. Now she's going to very carefully pour her sample into the flask. If you prefer, you can use a funnel for this, but remember, if you do, you have to rinse the funnel just like you have to rinse the bottle. Now Heather's going to quantitatively rinse her bottle here in a moment to give you a good demonstration of exactly what that term means. Put a little in the bottle. Shake it about. Into the flask it goes. Repeat this process several times. It's a good idea to put your thumb over the end of the bottle and shake it so that the entire interior is coated. Wash the entire interior of the sample bottle. You really can't be too thorough at this. And that was a good job. And now Heather's going to finish filling the flask. So using her DI bottle, she slowly fills it up until she's up to the level that she thinks is correct. There we are. Now she's going to cap the flask. And she's going to invert it several times, back and forth, back and forth. This will thoroughly mix the flask. And there's our sample ready to go. So next we're going to do an example run. We're going to go quickly through this, so hold on to your hats. First thing Heather's going to do is she's going to put her completed sample in a 150 ml beaker for stability. It's easy to spill these, and they're very fragile. She readies her pipette. And she draws up her sample. Checking it at eye level. When she's satisfied with it, onto the column it goes. Quick touch to the side to get the last drop. Cap the flask. And with a 250 milliliter Erlenmeyer under the column, Heather opens the stopcock. Now we see our sample draining down through the column. Notice you can tell that the top of the column is already capturing the copper ions. It's evident from the change in the color. Now we're going to let this run until it's almost completely ran to the bottom. Heather's pulled up 50 milliliters of water in a graduated cylinder. And now as we get down to the bottom of the column, she adds that water. Now there's no right way to do this. There's no right amount. You simply add all of the water as you can. It can be done in even aliquots, or it can be done as much as the column can hold at a time. What's important is to get the entire 50 milliliters of water ran through the column. So now we're down to the bottom of that, and we turn off the stopcock. Notice that we have still not let the column go dry. Very important. Never let the column go dry. We'll take our sample away and substitute a 50 milliliter Erlenmeyer. We will add 10 milliliters of water. We'll let that drain down. Once that's drained down, close the stopcock. And test our testing sample. 2 drops of phenolphthalein. Bring in the base. Now Heather added more base there than she needed to, but you saw that it turned with a single drop. The sample has a neutral pH. All of the acid that has been displaced has been eluted, you can be confident of your result.